Hi, welcome to the Chamber Chat. I'm Bruce Williams. I'm the CEO of the Greater Victoria Chamber of Commerce, therefore Chamber Chat. I'd like to begin, as always, by recognizing that I live and work in the ancestral lands of the Lekwungen-speaking Coast Salish nations, the Songhees and the Esquimalt. Program today is presented by two sponsors. One is Island Savings, a division of First West Credit Union, and the other is C-SPAN Victoria Shipyards. We're doing the broadcast, as always, from the podcasting studios of Czech Television. As we work our way through the pandemic, we saw a whole series of words pop up that we didn't really use a whole lot in the past. Words like pandemic, words like pivot. Something else that came along, ventilators. We're talking today about one of the things that was undertaken by a Victoria company, and as we like to put it in our terms, we are all on the recovery runway, taxiing toward our recovery, and the people that make change happen and help the pivot are the pivot pilots. Scott Phillips is a pivot pilot. He's the founder and CEO of a company called Starfish Medical. And Scott, thanks for being with us.
My pleasure. I've never been called a pivot pilot, so it's a pleasure to be here just for that.
Yeah, we're going to get little badges made up for you with wings on them and stuff.
Nice.
Your company is in the business of creating medical devices, which we'll talk more about in a second.
Right.
But we came to realize that COVID required ventilators for people who are having breathing problems. You started creating ventilators. Tell me about how that happened.
Well, it's a very complicated. You can imagine a life-sustaining complex device the size of a bar fridge with hundreds of pieces in it. It takes some doing. So, but in the early days of COVID, it seemed to be critically important. And so we just started us figuring out where in Canada we could find the right technology to build on, because there didn't seem to be any reliable supplier in Canada. So we found a technology in Winnipeg with some aid from the National Manufacturing Supercluster. And then ultimately we just started working on it. And then the federal government came in and awarded us a large contract to make 7,000 ventilators, which we did. We did the development. And I'll tell you the rest of the story in a minute if you ask me about that.
Sure. So how long does that process take? Once you undertake the plan, so we're going to create some ventilators, we're going to make them, we find the materials, you get the design in place. How long did that all take before you began manufacturing?
Yeah, so normally a process like that would take about 3 or 4 years. Because it's critical, you'd have to do all sorts of testing and supply chain integration. So this was an accelerated process. It was about 6 months until we were ready for manufacturing. And in fact, by the time we got through all the them rolling out and being delivered, it was more like 8 months. But that is smoking fast by comparison to what would normally happen.
So for people who are very much intrigued by moving parts and things that happen, they're probably dying to know, how do you do that? How do you actually make that creation happen? Where do you source the materials? How do you impose the design?
So you can imagine there's a lot of very special critical things that go into a ventilator. And this one was based on a piston design. So a large piston, very sensitive, very tight tolerance. And we did that because the world was scrambling after things that go into conventional ventilators. So we found various manufacturers, mostly in Ontario. That's where the sort of manufacturing infrastructure is for a lot of these pieces. And we contracted with a large manufacturing company called Celestica, based out of Toronto, to make. And we're talking many, many millions of dollars of product, right? So it's and all sorts of vendors. We had, I think, about 100 people on our staff worked on this project at one time or another. So it was just a giant effort.
So the government somehow got word of what you were doing, or did you go to them and say, hey, we can do this? Or they heard that you were doing this?
So actually, the manufacturing supercluster, which is based out of Ontario, they're somehow connected, and they connected us to the federal government, who was doing a sourcing exercise. And then we made a proposal as to what ours would look like. And so they picked us as one of 4 ventures that they would award all of us the contracts to make ventilators.
I'm not going to say this as a political statement because it has been admitted already by various people involved in the system, but we were somewhat unprepared for this pandemic when COVID came along. Proof being that you had to automatically create 7,000 of these ventilators. What do you think the go forward is? Will you continue to manufacture these, or is there enough of them now to manage what we need?
There's more than enough. So what's kind of what happened over time, that therapies emerged to avoid ventilators. Turns out by the time you're sick enough to need a ventilator, the ventilator is actually not that beneficial for you. Right? Some people did survive ventilators, but a lot of people went on ventilators and didn't survive. So it's kind of one of those things. At the beginning, they cast about and roll their dice, but turned out that really where our hope is more with vaccines and with therapeutic drugs. So we will be maintaining the ones that we made. we have hired a president for that new company we created for that, and we'll see what other opportunities he can unearth that leverage off those same strengths.
And did they all end up in hospitals, I assume?
They're all basically in Ottawa. There are some in hospitals,
Okay.
and any province can requisition them from the federal government if they want them. So
Okay.
we'll see how we go.
How does a ventilator work? What actually happens? What does it do?
Generally what they do is it's kind of like an electric bike, you know, when you try to push your bike, then it boosts the so it's like that for breathing. It'd be a kind of a simplistic way to think of it. And there's different modes, and they add extra oxygen, and you have to balance it, and some of them force the breathing, but if you imagine it as a breathing assist, that would probably be the simplest way to think of it.
Yeah, fairly intrusive, but life-saving.
Absolutely.
Yeah. Tell me about what else you do. If you go to the website for Starfish Medical, you'll see that you're involved with things like CT scans and MRIs a little bit. You do
Yeah.
cell separation. You do heart valve testing. Tell me about the stuff that
Yes.
you do on a regular basis.
Oh my God. So we do crazy things. They're all complex electromechanical things that go inside your body, or we did one that was an ingestible robotic capsule that analyzes the cells in your intestines and then radios out the results. So we have one that was for mapping blood flow in plastic surgery, or for Parkinson's therapy, injecting cells into your brain. They're all quite interesting, complex, high technology medical things for companies all over North America, all over the world.
So you're kind of an integration of science and technology. Is that fair to say?
Absolutely.
Yeah.
Yeah, absolutely.
Were you the kid that always took things apart just because you had to know how they
I
operated?
totally was. The knack. Go Google the knack and go find a fun video about that.
One of the things that I saw that you do, actually, you're involved with fungus removal. Tell me about that.
Fungus removal. Well, that's basically if you get to there's a common disease of fungal infection of the toenails, where it makes sure that onychomycosis, they think they call it, and so we did a product for that a few years back.
Yeah. Your team must have rallied around this, and there must have been a great deal of pride in what you were doing.
There certainly was a lot of them. We had about 40 full-time people on it, so that's a big team for our company. And we had people working all hours of the day and night trying to get these things put together. That was wonderful from that regard.
Well, congratulations. Thanks for doing all that, and well done.
Thank you so much.
Victoria Company, Starfish Medical. Check them out online. Scott Phillips is the founder and the CEO. Another response to the pandemic happened in Greater Victoria. That one was through Camosun College. It involves the movement around of the actual vaccine themselves. We're going to talk about that now on our next part of the Chamber Chat. So Richard Gale is with us today on the Chamber Chat. He is the director of Camosun Innovates, which is a center at the Interurban campus. Richard, how are you?
Good, thanks. How are you doing today?
Good, thank you. Yours is a building that if people were to drive past the Interurban campus, there's the brand new trades building. You're kind of across the road from that. It's one of those things where amazing things happen, but you just can't tell from the road what's going on inside. So tell me a little bit about the center, about Camosun Innovates.
Well, we're the Applied Research Center for the campus, and so we work with a lot of students and faculty who are doing research projects as part of their curriculum. But we're also a technology access center funded by NSERC to support small and medium-sized enterprises in the Lower Island and really throughout British Columbia.
You create prototypes and things like that, right?
We create prototypes. We do a lot of fee-for-service work. We basically bring ideas to the marketplace for any company that doesn't have a research and development office of their own.
So the students are in what curriculum? Are they mostly engineering or what?
Most of our students are in engineering, but depending on the project we're working on, we'll draw students from all over. We do a lot of work with Indigenous artists, and so we have visual artists working with us. We have psychology and sociology students working with us. It all depends on what the project needs.
So if you wonder where your tax dollars go, sometimes it's into very worthy projects like this. All of us, of course, have a collection of masks now because we've been able to find a supply to keep up with the demand. In the early days, though, you did something there that would help people by creating face shields. Tell me about that.
Well, originally, when the call first came out for support for various health authorities, we were in a meeting with Island Health, and they were talking about the things that they were most in need of. N95 masks was at the top of the list, but we don't have the facility to do anything about that. Then the second on the list was face shields. And so we decided rather than try to simply tackle that problem the way it had been done before with 3D printing, we decided to try a new way forward. We had a gentleman working with us, Matt Zeleny, who designed a complete face shield that could be completely made with laser cutting. Wow. And so we managed to reduce the cost of face shields and reduce the time that it took face shields to be made with this new design. And then we partnered with AP Plastics, a local business, to make them en masse for Island Health. We ended up producing 9,000 of those shields in-house for Island Health. And then I think there was another 10,000 made by AP Plastics for healthcare providers.
Amazing. So then the word came out about the vaccines and having to move the vaccines around and the time factor because they have to be kept at such a cold temperature. Camosun stepped up again. So tell me about what you did.
We got a call from BC CDC saying that they actually had two problems that they were facing. They had difficulty getting the vaccines from the central location to remote communities and remote sites because the vaccine had to be kept as stable as possible. If it sloshed around too much, it had to be left to settle before it could be administered. And so they asked us to look into some way to take what were boxes of almost 200 vaccines and reduce them into a smaller number for shipping, but also in a way that the vaccines wouldn't slosh around. All of this at 70 degrees below Celsius in a controlled environment. So the first thing we did is we started looking for materials, and we determined that there was an acrylic that we could use that would go down to 150 degrees Celsius and could be cut also on the laser cutter, and that we could create a tray that would hold any number of vials necessary up to 100. We designed it so that it would be 4 quadrants, each of 25 each, so it could be easily seen at a glance how many vaccines were there, how many vials were there in the tray. And because it could be done quickly, you could see these at a glance, they could meet their 3-minute window, which is how long they had to fill a box to go to a community elsewhere. To make that even faster, we designed a grabbing tool that you could grab 5 vials at a time and thereby load the box and get it on its way in record time.
Okay, so where did you source the acrylic? Where did that come from?
The acrylic was locally sourced, actually. I think we worked through a number of local plastics dealers there.
So when the team gets together and everybody starts to noodle on what we're going to do here, who are those brains? What's the team that comes together to create the design and the prototype and then make it actually happen? So tell me about that process.
So the person that was pretty much at the front of that was Sergio Solares, and he is an engineer. He is our project coordinator, and he runs the shop. He was helped mainly by, again, Matthew Zeleny, who has been with us for more than 10 years. He is also an engineer. He's our chief technologist in the areas of 3D printing, AR, VR, pretty much our computer go-to guy for anything that needs to be programmed. We worked with Andrew Birch, who is a Mech Eng student who graduated last year and is working with us as his first job. And Joe Bradley, who is another Mech Eng student who is working with us right after finishing his program at Camosun.
So the key to that, they're students. Students are working on this as well as people like yourself that are on faculty and staff. That's pretty cool.
Yeah. With the exception of Sergio, all of our technicians have been students with us before.
Well, that's got to look good on a resume that you've been a part of a project like that.
Yeah, yes, it is.
Yeah. When you talk about 3D printing, I think that's something that a lot of people have heard of. They don't fully understand it. Did 3D printing create these vials and these materials?
No, we didn't use 3D printing for the vial delivery system.
Okay.
That was primarily for the clamps, for the handles that we made for them.
Yeah, because when I watched the video of what you're doing there, summer job once when I was in university, I worked in a factory chroming pistons. So if you know what a piston looks like, it's got a round top with a stick down on the bottom. We had to pick them up by the handful and load them into these crates. So that's why you developed that grip thing, right? That's what that does.
That's right. So that was 3D printed because it didn't have to be in the low environment for very long. It's hard to get 3D printed products that can be sterilized at a high temperature and also capable of withstand lower temperatures.
Yeah. Is there an easy explanation as to what 3D printing is or how it works?
Sure. You take a whole bunch of plastic and you shoot it through a few nozzles, and by layer, you add this material to whatever it is you want to create. So it's what we call an additive manufacturing process. You're not taking things away from, say, a block of stone or a piece of wood. You're adding plastic and different kinds of material to it to create what you need.
And it's by robotics, I assume, right?
No,
No?
no. 3D printers, technically, I guess you could say it's robotic in that there are arms that go around to introduce the material, but it's not robotics the way that we think of robotics, taking something from one place, moving it to another,
Mm.
doing a new series of activities. We do work in robotics and automation, but this wasn't used for this.
So this project you did with, you talked about the face shields, but the vials and how many of those have you managed? How many units have you created?
For the vials, for
Yeah,
vial distribution, we've created just under 500 trays
cool. And where are they going to go?
all over the island. Originally, the idea was that they would be reused, that they would fill a box, take the tray, send it to a location, and then it would come back and be cleaned and reused. But we found out almost immediately that most of the locations we sent them to liked them and decided they weren't going to send them back. So hence making a little more of them.
And you're also, actually, just to wrap it up here, you're working on helping breweries and distilleries do some retooling. Tell me about that.
We are. We're doing a lot of work with local businesses, and during the pandemic, one of the sectors that we found we were able to support was breweries, distilleries, even cannabis producers, looking at new ways to create new beer flavors, new approaches to non-alcoholic beer, new ways of distilling various products, new ways of using cannabis byproducts. So the time was not wasted by our local small and medium-sized enterprises at all. And we've been trying to support them while we're supporting the health authorities.
It's amazing work. Richard Gale, Director of Camosun Innovates at Camosun College. Thanks for all you did, and thanks for being with us here today.
Thank you.
And speaking of retooling breweries and distilleries, we're going to talk about that next on Chamber Chats. So things during the pandemic have been disruptive in the beverage industry and for the brewers and the distillers and the vintners and all the rest of them. David Nichols is with us. He's the GM and one of the partners at Vancouver Island Brewing. David, how are you?
I'm doing great on this sunny day.
Yeah. So all of this came along. People saw that there were stats saying that, well, consumption of alcohol is up and we're drinking more in the pandemic for whatever reason that might be, which would make one think that everything was dandy in your sector. Not necessarily. It depends on where the product was being sold. So tell me about that.
Yeah, and we always got to dig into what are the questions when asked. We're drinking more and we're consuming more because in BC we're actually consuming less. The bars and the restaurants make up a significant amount of volume in our industry, and some craft breweries are 20% to 50% of their volume could come from bars and restaurants. So as much as we saw a lift in our retail sales, it doesn't make up for the loss that we saw by not selling kegs within that bars and restaurant channel. And even when it came back, it was at a much less volume.
Right. As we explained off the top, we at the Chamber with our advocacy say that we're on a recovery runway as we taxi down the runway to the recovery through all of this. And the people making change are the pivot pilots. And you're a pivot pilot because you actually had to, in the very initial stages, had to bring a lot of product back into the brewery that wasn't going to be sold at various sites. But you didn't just dump the beer down the drain. Tell me what you did with it.
Yeah, absolutely. Clearly, there's lots of bars and restaurants throughout BC that sell one of our beers. Mount Washington is another great partner of ours, and there was a significant amount of beer up there. We were heading into the spring break holidays last year, and there was a lot of draft product out in the marketplace. And so we did our best to bring back as much as that product. We had product in warehouse, we had product in our own warehouses, but just as you said, we didn't want to be making waste of this. And within our industry, there had been talks of converting the beer into a hand sanitizer. We don't have that capability to do that here. But when we reached out to the marketplace, the great folks over at Stillhead in Duncan put up their hand and said, hey, we can convert your beer into a hand sanitizer. And so we started the logistics process of transferring not kegs up to them, but transferring it into totes that they'd be able to use within their process.
So what's the science behind that in a way that I can understand? But how do you do that? How do you remove the alcohol from the beer and turn it into hand sanitizer?
Yeah, well, it's essentially almost the opposite of what you said. You're not removing the alcohol, you're trying to add up all the alcohol. So in order to be a hand sanitizer, and I'm not on the science side, I believe it's 40% is that the alcohol level needs to be at. And so simple math is it would take you, 4 liters, get my math right, 8 liters of beer to make up 1 liter of hand sanitizer.
Okay.
Right? Because you're taking the 5% there and just add all your 5%. So there's your 40%. You can't have a hand sanitizer that's, that grand. So they distill out all the other stuff and just keep the alcohol.
Okay, so that was a pivot that you made right then. And where did that sanitizer go?
Yeah, so Stillhead, again, did a fantastic job. They worked on the weekends. They donated their time to make this happen. And that product ended up going to both frontline staff as well as elderly homes. Right. They helped us out here while we were needing to get hand sanitizer as well for our own staff and production facility here.
Right. Your brands are very familiar to people, Herman's Dark Lager and Pipers. And tell us some of the other brands just so they can understand who we're dealing with here.
Yeah, a lot of people will know us for those brands of Pipers and Herman's and Herminator and Islander. They're still a part of our portfolio. But now our number one selling beers are Victoria Pilsner and Broken Island's Hazy IPA, as well as our West Coast IPA that we just launched recently, just a couple of weeks ago.
Great. And your Orca pack was very interesting. That was something that had a philanthropic side to it. Tell me about that.
Yeah, so in 2019, we launched our Pod Pack program, which was a collaboration with 4 other breweries on the island. So we worked with each of those breweries to create a unique beer for this pack. Basically $1 from each pack that we sold went to support the Pacific Salmon Foundation. We did take a pause in 2020 with the uncertainty around the pandemic, but now that we're clear on the challenges that it's faced with, we wanted to get right back on board supporting the Pacific Salmon Foundation because it is such a critical piece to our island and the surroundings that we have in our wonderful waters. So we'll be coming back with it, and we got 4 new great craft breweries that we're working with off the island, or on the island, I should say. Some of them are actually in the Gulf Islands, which is pretty exciting for the first time for us. And that's been a unique challenge, just as we do things all virtually. But it doesn't stop us from raising the amount of money and getting those funds towards the Pacific Salmon Foundation. So you'll be seeing that coming out in May this year.
Great. David Nichols, GM and partner at Vancouver Island Brewing. Dave, thanks for all you're doing, and thanks for your time today. And yes, they have a patio. It's on Government Street near Bay. You can have a beer on the patio for sure. David, thanks very much.
Absolutely. Thank you.
That's our Chamber Chat for today. Thanks once again to our presenting sponsors, Island Savings, a division of First West Credit Union, and C-SPAN Victoria Shipyards. You will find this podcast, of course, on Czech Television, also posted on the website of the Greater Victoria Chamber and the Czech website, too. Thank you all for watching, and we'll see you for the next Chamber Chat.
For more episodes of Chamber Chats, go to czechnews.ca/podcasts.